FastMCP 3 implements cursor-based pagination through the list tool's MCP method, enabling controlled, incremental fetching of tool collections from the server. This asynchronous pattern allows clients to process results in manageable chunks while maintaining connection efficiency. The upcoming code demonstrates how to initialize a client connection and iteratively request pages of tools using cursor tokens, with each response containing both the current batch of tools and a reference to the next page when available. From FastMCP import client. Async with client server as client. Hash fetch first pay. Result equals await client. List tools MCP. Print page 1. Len result tools. Hash continue fetching while more pages exist. While result next cursor. Result equals await client. List tools cursor equals result. Next cursor. Print next page. Len result tools. This code demonstrates cursor-based pagination for controlled tool fetching using FastMCP3's list tools MCP method. The pattern implements incremental data retrieval, where the client first fetches an initial page of tools, then uses the returned next cursor to fetch subsequent pages until no more results remain. This approach is particularly valuable for large datasets, as it reduces memory pressure on both client and server while enabling progress tracking and early termination. The implementation follows a straightforward loop pattern. Fetch initial results, then iterate while a cursor exists, passing it to subsequent requests. The cursor itself is treated as an opaque token, abstracting away the underlying pagination mechanism. This design choice provides flexibility for server-side implementation changes without breaking client code. The trade-off here is between simplicity using the convenience, list tools, method, and control manual pagination, with the latter being essential for memory-constrained environments or when processing large tool collections incrementally. From a production perspective, this pattern becomes crucial when dealing with dynamically generated or numerous tools, as it prevents overwhelming the client with a single massive payload. The code shows how FastMCP 3 maintains backward compatibility through convenience methods while offering fine-grained control via the MCP variants. The explicit cursor handling in this example contrasts with the automatic pagination of list tools, giving developers the choice between simplicity and control based on their specific requirements. Let's break it down. From FastMCP import client. Imports the client class from the FastMCP module, making it available for creating FastMCP client instances in the current scope. Async with client server as client. Establishes an asynchronous context manager for a client connection to the specified server. The async with statement ensures proper resource management, automatically handling connection, setup, and teardown. The client instance is bound to the variable client for use within the context block. Result equals await client. List tools MCP. Calls the list tools MCP method on the client object asynchronously using await, then assigns the returned value to the variable result. The method appears to retrieve a list of tools related to MCP likely FastMCP tools, and the await keyword indicates this is an asynchronous operation that will suspend execution until the list is fully retrieved. Print page 1. Len result tools. Prints a formatted string that displays page 1, followed by the count of tools in the result tools collection, obtained using the len function. The output shows how many tools are present in the first page of results. Hash continue fetching while more pages exist. While result next cursor. Continues looping while the next cursor property of the result object evaluates to a truthy value, indicating there are more pages of data to fetch. The loop will terminate when next cursor becomes falsy, typically none or empty, signaling the end of pagination. Result equals await client. List tools mccursor equals result, next cursor. Calls the list tools MCP method on the client object asynchronously, passing the next cursor value from a previous result to retrieve the next page of tools. The await keyword indicates this is an asynchronous operation that will yield control until the response is available. Print next page, len result tools. Prints a formatted string showing the number of tools available in the next page, where the count is determined by the length of the tools attribute in the result object. The output follows the pattern next page, X tools, with X being the actual count. Cursor-based pagination in FastMCP 3 provides a controlled way to fetch tool collections incrementally, balancing memory efficiency with connection optimization. The pattern starts with an initial request to list tools MCP, which returns both the first batch of tools and a next cursor token. This token then drives subsequent requests in a loop, with each iteration fetching the next page until next cursor becomes falsy. The asynchronous context manager ensures proper resource handling, while the opaque cursor token abstracts pagination details from the client. This design offers flexibility for server-side changes without breaking client implementations. The trade-off between simplicity and control is evident here. While convenience methods like list tools automate pagination, manual cursor handling gives developers fine-grained control over memory usage and progress tracking, making it ideal for large datasets or constrained environments. The loop structure is straightforward. Fetch, process, and repeat until no more data remains, ensuring scalable and efficient data retrieval.
The list sleeps through pagination, while the cursor sprints. Both arrive at the same tools, one without moving,